everyone at home. We miss you here at school. Hope you guys can come back before break and we can see you a little bit and have some fun with the movie on one of the last few days. Today you're going to learn a new lesson. You guys have never been taught this before. It's going to be very similar to graphing equations. You guys already know how to graph a linear equation. The only difference is today that we're going to graph a linear inequality. Okay, so if you think about when you graph a linear inequality, how we learned with just one variable. Let's say our answer was like x is greater than 3. We would put 2, 3, and 4 on a number line, and because it was a greater than and not a greater than or equal to, we did an open circle. Now we're going to have something similar to the open circle, but it's going to be a little bit different. But keep in mind that that open circle means that 3 is not part of our solution. Okay, so that's what the open circle means. Again, today you'll have something different, but that means that it's still not part of the solution. And then we had to shade. So where were numbers greater than 3? Well, it was on the right side. Okay, so that is how we did it whenever it was just one variable. Today it's going to look more like y is greater than 2x plus 3. How do we graph them on the coordinate plane when there are two variables? Okay, so that's our goal. We're going to go through a few examples and some steps here. So first off, let's just know how to determine if something is a solution or not. Okay, so we did this with equations. We just hadn't done it with inequalities yet. So if I'm given a point, we always know that the first number is the x and the second number is the y. So to know if it's a solution, just like on equations, plug in the x and plug in the y and see if the inequality is true. So -5 is less than 4 times -2 minus 3. We got to see if this is true. So let's clean this up. -5 is less than, let's put that together, -8 minus 3. And one more step. -5 is less than -11. Is that true that -5 is smaller or worse off than -11? No, that's not. -5 is bigger in value. Okay, so let's try this again with a different inequality. Again, -8 is your x and -7 is your y. So let's plug these in. -8 minus, now we have a minus here, but there's also a negative there. So technically it's minus a negative, or you can fix that to a plus right away. Double negative is greater than a -5. All right, so again, let's clean this up a little bit more. -8 plus 7 is -1. Is -1 greater than -5? Yes, it is. So that point was a solution to the inequality, whereas the first one was not. Okay, so this is going to come into play here in a little bit, but then I'll also give you hopefully a shortcut that will make sense. All right, so we are going to graph this equation, y equals x plus 1. So we're going to go back to equations really quickly. Okay, so if I plot this point, if I plot the y-intercept, I'd start there, use my slope of 1/1, so up 1, right 1. We did this last chapter, and we also did it last week with linear systems. Okay, so let's see. Is the point 3, 4 true if I plugged it into y equals x plus 1? Well, 3 plus 1, is it 4? That's true. Let's see where that point was. 3, 4. Ah, that makes sense. It was on the line. Okay, let's try another one. Let's plug in 0, 3. So is 0 plus 1 equal to 3? That was false. Let's see where that point was. 0, 1, 2, 3. That one was not on the line. And let's try the point 2, -3. So 2 plus 1, does that equal -3? No, it does not. So 2, -3 was not on the line. So what do we notice? We notice that the only one that was actually a solution, the only point that was a solution to this linear equation, was the one that was on the line. And that's exactly what the line is. That shows us all the possible answers that make this equation true. And we draw the line and the arrows at the end to show that it goes on forever, because there are an infinite amount of points that would make this equation true. But that doesn't mean every point makes it true, because we just saw 2 points that did not work. It has to be points that occur on this line. Okay, so keep that in mind, because on inequalities, we're going to have a line, but we're going to have some other points as well. So kind of foreshadowing here. Let's first start with our steps. Okay, so the first thing we want to do when we are given a linear inequality is to put it into slope-intercept form. Now I'm guessing most of you know the answer to why on this one. We want it in that form because that's the way that's very easy to graph. Okay, so let's put it in y equals mx plus b so we can graph it. And then we would graph it as we normally would. We would put our points. Now here's the catch. When you put the points on your graph, do not connect them right away, because sometimes we are going to have a solid line like that. And then other times we are going to have what we call a dotted line. And you want to make sure that you can tell the difference between the two, because it's really important. And if you remember when I talked about graphing before the lesson started, and I said that there was a difference between open versus closed circle, this is where it kind of makes that connection. So if it's equal to, it's part of our answer, so we want to shade it. So we were going to have a solid line if it's equal to. If it is just less than or greater than but not equal to, it's not part of our answer, so we don't want to shade it. So we show a dotted line, again, to show that it's not part of our answer, so it's not included. It wouldn't work if we plugged them in. The points on that line would not work if we plugged them into the inequality. Okay, so then we would pick a point either above the line or below the line, not on the line. So pick a random point above it. We're going to test it out. If that part is, if that point is a solution, then we are going to shade that part of the line. Okay, so if we plug it in and it's true, we're going to shade on that side of the line. So it would kind of look like this. We would shade the entire half of that graph. However, if it's not true, we would shade on the opposite side. So if it wasn't an answer, we would know that no other points on that side would be answers either. All the answers would have to be on the other side. Again, it kind of relates back to our original graph here. You either shade one side or the other. You can't shade both sides. And so that's a lot of times the toughest part of this lesson. So I'm going to show you how to do it with choosing a point. And I'm also going to show you how to do it hopefully with a little bit of a shortcut. Okay, so let's practice here. Okay, so I'm going to first graph. Notice these two inequalities are almost identical, except the second one has an equal to. So I'm going to kind of graph them at the same time. They both have a y-intercept of 1, so let's put a y-intercept of 1 on both of them. They both have a slope of 1, so up 1, right 1, up 1, right 1. Notice this is actually the exact same graph that we did with y equals x plus 1. Only difference, these are less than and less than or equal to. Okay. Again, I said don't connect the dots right away. We have to either do a solid or a dotted line. Okay, solid means that the line is part of our solution. So if it's equal to, that line is part of the answers. If it's less than, that line is not part of our answers. In other words, if I would plug in this point right here, 0, 1, and I put it in there, is that true? Is 1 less than 0 plus 1 or 1? No, it's equal to. So it's not part of our answer, and to show that it's not part of our answer, we do a dotted line. Again, still put the arrows showing that it goes on forever. Okay, so that's half of it. The shading a lot of times is the hard part for people. Okay, so here is one way that you can do it. You can pick a random point that's not on the line. So I'm going to pick 0, 0. That's an easy point to plug in, and I'm going to test it out. So I would put in 0 for my y and 0 for my x. Is 0 less than 1? Yeah, it is. So that is a solution. And remember, I have to shade my solutions. So because this is a solution, I would need to shade all of the points on that side. And I only have to test one. If that one point works, that means all the points on that side are going to work. If it didn't work, I would have shaded the opposite side, but that wasn't the case. It worked, so I shaded the side that it was on. Okay, so I would do that. And I would do that same one over here. Is 0 less than or equal to 0 plus 1? Well, 0 is less than or equal to 1, so I would shade that side. And just to kind of prove a point, I'm going to pick another point. Let's do 0, 4. So if I chose a point above the graph this time and plugged in 0, 4, well, 4 is my y and 0 is my x. Is 4 less than 1? No. And so that's why this side is not shaded. It is not a solution. All the points on this side, if I would try them out, they would not work. Okay, and so that is one way that you could do it. Here is what I say, and I think is a shortcut. But if this confuses you, you can stick with choosing a point. But this is, in my opinion, the quicker way of doing it. So I put my pen or pencil, whatever you're using, on a point on the line. So I'm just going to put it right in the middle. I know that this symbol is a less than symbol. And I ask myself, do you think you go up or do you think you go down if you see the less than symbol? Well, less than, your brain automatically thinks down. And so guess where I'm going to shade my graph? Down. I'm going to shade it, everything below it. Again, I see a less than or equal to symbol. I put my pen there and I think down. So I would shade anything below that line. And that's, in my opinion, the shortcut. Okay, so you can see the 3 different graphs that we did. We started off with y equals x plus 1. That was a solid line. Only solutions that are available, or the only actual solutions, are the points that are directly on this line. This graph, the line is not part of our solutions. The only solutions to this inequality are the ones shaded below. Well, this graph kind of joins the two of those. Everything on the line was a solution because it was equal to, but it was also less than that. So it's also the ones below. So it's on the line and below are our solutions. And that is kind of how they are the exact same line. They're the exact same points that make the line, but there are different solutions. Each one is a little bit different. Okay, so let's try a couple more. And let's try to use the shortcut this time. So I'm going to graph y is less than 2x. So I would imagine that this was just y equals 2x. So start at 0, go up to right 1, up to right 1, and we can go the other direction as well. Now, be careful when it comes to putting your line, because we have to first see if it's solid or dotted. Well, it's not equal to, so this line is not part of our answer, so I don't want to shade it. I want to make it dotted. Okay, here's the shortcut. I'm going to pick any point on this graph. I'm going to pick 0, 0 here. And I look at my symbol, it's a less than. So do I go up or do I go down from this point? Less than, down. So since I went down, I am going to shade everything on this side of the line. So I'm shading everything below that line. And I have to shade the entire graph. Okay, so don't just shade like a little part of it. We can shade everything below that line. Okay, so let's try another one. I'm going to start at -1. My slope this time is -1, so I have to go down and to the right and get more points. Again, don't connect it just yet. See if it's dotted or solid. Well, it's just greater than, not equal to, so the points on this line are not part of our answer. So again, we do dotted. Still do the arrow showing it goes on forever. Okay, this time it is a greater than symbol. So again, pick any point. I'm going to pick this point this time. Greater than, I think up. So I need to shade all of the points that are above this line. And that would be our answer. So any point in this shaded region is a solution. So I could pick a point. Is this point here a solution? Yes, it is. Is this point a solution? Yes. Is this point a solution? No, because it's not in the shaded region. So it's kind of a quick way to see where all of your answers are. Okay, so let's try a few more. We've got 3 slides left. This is different, so it takes a lot of practice with it. Okay, so let's start at our y-intercept, which is 2. Let's go up 1, right 3, and down 1, left 3. Again, don't connect your points just yet. This one is a less than or equal to. Equal to means it's part of our solution, so we can shade or make that line a solid line since it's part of our answer. And if I would shade, I pick a point. Less than means down, so I'm going to shade all of the points below that line. All right, this is the one that's a little bit tougher. I'm going to graph the line x equals -3. So remember, this is one of our special ones. It's either a horizontal or a vertical line. So I find my x-axis. I find where -3 is on our x-axis. Well, that's left 3. And I have to figure out where all of my points are where the x is -3. So that's -3, 0. This would be -3, 1, -3, 2, -3, 3. And you can see that this graph makes a vertical line. Okay, since it was greater than or equal to, I'm going to have a solid line since that line is part of my solution. Now, some people get tripped up by the shading of this. If you think of just a normal number line, this would be -4, -3, -2, oops, -4, -3, -2, -1, 0, and so on. We have a greater than symbol. I can't pick a point on this one and shade up. It's the only one I can't whenever it's a vertical line. It's not possible because it's part of our line. So I have to think, where are the x values greater than -3? Are they on the left side or are they on the right side? Well, all the numbers that are greater than -3 are on the right side. So I would shade the entire right half of this graph. And that would be my solution. All right, last 2. This is as complicated as it's going to get today. We are going to have to notice this is given kind of in standard form, except there's a inequality versus an equation. So we're going to have to manipulate this equation a little bit to make it in slope-intercept form. So I'm going to first off copy it down. All right, so I'm going to get the y by itself. So I'm going to send the 4x to the other side by subtracting it. So I would have 2y is less than -4x plus 2. Okay, now I don't have y by itself yet, so I am going to divide by 2. Again, remember we divide everything by 2. So this would give us y is less than -2x plus 1. All right, so if we're graphing this, we start at 1, we go down to right 1, down to right 1, and up and left. Now remember, be careful about drawing your line right away because you have to look at your symbol. It's a less than. That means that the line is not part of our solution, so we make it dotted. Right, shading, less than. Find a point. I'll pick the top left one here. You think less than, you think down, so we are going to shade everything below that line. And that would be your answer. Okay, let's try one more here. Last one like this. So again, 2x minus y is less than 3. I am trying to get the y by itself, so I'm going to send the 2x to the other side by subtracting it. I'd get negative y is less than negative 2x, and we had a positive 3. And then I'm going to divide everything by negative 1. Here's where it was different than the last one we did. Remember what happens when we divide by a negative? We have to make sure to flip that inequality symbol. So this is going to be y is greater than 2x minus 3. And so when I graph this, I'd go down 3. I'd go up 2, right 1, up 2, right 1, up 2, right 1. It's greater than, so not part of our solution, so we make this line dotted. And shading, we flipped it to greater than, so we're going to use that final symbol, greater than, to help us graph. So put your point on any, or your pen on any point, greater than you think up. So I have to shade that half of the graph. And that's our solution. Okay, so the last thing we're going to try to do is, if I give you two graphs, can you write the inequality for the graph? Again, this is very similar to equations. So let's practice by pretending it was an equation. So y equals mx plus b is our goal. Write it like that. Okay, so y, I'm going to leave out the equals because I know I'm going to change that eventually. I know my starting point on my y-intercept is 2, so I know it's going to be a plus 2. Need to get another point to find my slope. Well, it looks like the pattern is up 1, right 2, up 1, right 2. So our slope would be 1/2, and then I'm going to put the x after it. Now, here's the only part that's going to be different. Can't leave it as an equals because there's shading. Shading means it's an inequality. Okay, so first thing I want to look at, is it dotted or is it solid? Solid is what this one is, so that means that there has to be an equal to, and it's shaded above you think greater than. So our final answer is y is greater than or equal to 1/2 x plus 2. All right, last problem. Again, I'm going to pretend like it's y equals mx plus b. I'm just going to leave out the equals. My graph on this one started at -2, so I know it's going to be a -2 in the end. Okay, so get more points here to find my slope. Looks like the slope is down 1, right 1, down 1, right 1. That means my slope is -1. I'm going to put the x behind it. All right, so this time it's a dotted line, so I know it's not equal to. And if I picked a point, I would have shaded below, and below, I think, less than. So y is less than -1x, or you could have written this as a better way of writing this is y is less than -x, and then -2. All right, hopefully this video was helpful. There is homework tonight. I also posted the answer key so you can check your answers afterwards. If you have any questions, don't hesitate to send me a message on Schoology. All right, see you guys.